Welcome everyone to another GraphGeeks talk, knowledge graphs for AI agents and using AI agents with knowledge graphs and MCP servers, the modal context protocol servers, which is really exciting right now. We're very lucky to be joined by Will Lyon and Kevin Van Gundy of Hypermode. I've worked with both in the past. They are both extremely knowledgeable and a lot of fun when you're presenting. So not to set the bar too high, but I expect entertainment and knowledge on this one.
Hi, y'all. Nice to meet you. I'm Kevin. I'm going to tell you a bunch of stories about my family farm and maybe a little bit about AI agents. All right. Quickly into the agenda. As Hypermode, I'm going to tell you a little bit about Hypermode. Then we're going to spend a lot of time walking through kind of the construction of agents. And we're going to tell through the lens of my family farm. We'll build some stuff. Non-determinate systems are fun. Demoing live is always an adventure. And then Will walk us through the launch. This is the preview of Dgraph V25, as well as Dgraph's MCP and graph tools. And then last, we'll talk about how do we string this all together with a bunch of fancy code. And Will is then going to walk us through Modus. It's a lot of content. We'll try to move relatively quickly. But again, questions are wonderful. Interjections are wonderful. So the thing I like to start with in terms of setting the table of how do we think at Hypermode about agents? Really, I'm a big believer in, if you've been an AI nerd for a long time, in the late 80s, early 90s, there was this premise of a thing called expert systems, where we've had this emergent practice of building machine learning models. When you created a really narrow domain, you could actually score really, really highly and have these really effective models. And so you ended up having, you call it XCon, where you'd be able to orchestrate these systems of narrow expert systems. If you squint and look at today's universe of multi-agent systems, we're actually doing something quite similar, where we are creating agents that are deep experts at NDA creation, underwriting, or specific phase within underwriting. And then we build coordinators that allow us to orchestrate all of the systems. Hypermode is a believer in that's primarily the future. I am rather bearish on single omniscient agents or answer engines. I think they're great for specific use cases, but for automating and delivering, I think, a lot of the value we expect out of these new models, really the multi-agent system of experts is going to be the way in which it is easier for large enterprises, for individuals to adopt. When we think about the core capabilities of agents, there's obviously like the central nervous system of reasoning. And then very quickly, you start to say, okay, the model is not enough. How do I actually coordinate, usage of this model? How do I actually make sure that I'm not having to dump a 400 paragraph long prompt into the model and say, hey, remember, I do this thing. I'm Kevin. I like it when you talk to me this way. How do we coordinate those pieces? And also, how do we actually have the agent or the AI system observe and learn about us over longer periods of time? Hey, when I talk to Will, I know that Will loves emojis, but when I talk to Derek, my head of design, he does not like emojis. How do we keep track of those sorts of things? How do we keep track of facts about our universe? And that bridges really nicely into the world of graphs, which is, what is the world's greatest representation of knowledge and context? Well, gosh darn it, it's a graph. We've been studying this since the RDF universe with Sparkle and all of these crazy open world knowledge graphs. We're seeing that as the emergent pattern to actually be able to say, hey, the disambiguation problems of the Jaguar runs down the street. If I have a knowledge graph that's backing, hey, we're talking about automotive manufacturers in Detroit, Jaguar is probably a car. We're probably talking about an asphalt paved road. But if I'm working for UNICEF and we're talking about preserving, jungle cats, instantly, our agent or our reasoning system should immediately know, okay, access this part of my knowledge, the knowledge related to, jungle cats, whatever it may be. And so we tend to break apart kind of the three-part architecture into models, apps, and graphs, very similar kind of like what the 12-factor app of the cloud native system. Finally, I start to shill Hypermode. I promise very briefly do this. The thing that we believe is most important for being able to build systems that work well is how quickly can you iterate? Data science, agent creation, machine learning, AI, these are all emergent practices, meaning I need to try dozens, if not many dozens of permutations to find the local maxima to solve my problem. And it may turn out that the 12th iteration was actually the local maxima of identifying whether or not a underwrite or a invoice has an issue on it. But I need to try all 36 permutations of models. Do I need 4.5 preview? Do I need 4.0s, 4.1? Should I use Claude? Should I use this? Should I use that? Should I be using a different retriever from my knowledge graph? Should I be pulling in different tools? For example, if you are new or if you've started to build in the agent universe lately, MCP servers have made it really great for our agents to discover tools. But the problem is sometimes the agents are bad at picking what tool to use. Where if you use the GitHub tool, sometimes it wants to use a natural language search tool versus a code search tool, and it'll end up not being able to find the repo you're looking for. And so being able to test and tune all these different ways of instructing my agent how to work, the faster you can do that, the better and more quickly you're actually going to receive value out of your agent. And at Hypermode, we say, hey, we're going to give you one of everything. You don't necessarily have to use all of it. You don't necessarily have to use all of our first-party tools. If you love Weaviate, we partner heavily with Weaviate. You can bring their vector store to bear. Actually, as the GraphGeeks community, if you love Neo4j, cool, bring Neo4j. Modus has integrations with it. And we really just want to make sure you have one of everything so you can actually do this iteration process quickly. And we provide obviously all as like a hosted SaaS service. It's amazing, blah, 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 all that good stuff. And so starting to talk through what we think the right flow is for building agentic systems, there are two pathways within Hypermode, one of which is code first, where we have an open source framework called Modus, and you can just start hand rolling your agent. It's a very low abstraction framework oriented around very scaled workloads, high levels of concurrency, which works well. But again, to that earlier conversation of how do we figure out what the right mix is going to be? We found the fastest way is actually through kind of this, I hate the phrase, but vibe coding process, where I can have a prompt and say, hey, I want, dear Hypermode, please help me solve this problem. Behind the scenes, we're essentially going to discover the tools, the actions, the reasoning model. How do we make this piece work well for you? And we generate essentially an agent for you to then work against. Then we'll say, hey, by the way, this is Lexi. She's your sales ops analyst. The actions that we've prescribed to her are XYZ. These are tool servers. This is the model we're using, but all of this is configured. And then you can start to interact with this agent in a low-code way, figure out, hey, go do this work for me. Does it work? Oh, not quite. Okay, I need to change my prompt. Oh, gosh, it didn't quite work. I don't have access to that, Gong transcript or whatever it may be. And you're able to really quickly iterate through being able to describe the work you actually want it to have done. I think fundamentally humans are awfully bad at describing what we actually want. If you are a product manager or an engineer and you've ever looked at a product design document, it really only covers maybe 10% of the actual product design. The other 90% are things that you all have discovered about each other of when Kevin says, I want it to be fast, it means this. When Derek says he wants it to be beautiful, it means this. And for an agent, at least the first time you work with them, they don't have all of that tribal knowledge. And this chat mechanism allows you to essentially instantiate that knowledge into the agent or the series of agents. You can continue to expand and add to these things, add new actions, add new triggers. Hey, do this weekly, do this every morning, do this on a webhook. And you can swap out models as new models evolve and come through. And the big magic trick of Hypermode ends up being you can always eject to code. Especially for me, sometimes you hit a roadblock. If you ever used things like Wix in the early days or Webflow, where you design this beautiful website, but then eventually, I just really want this animation to do this thing instead. I always needed to reach for being able to actually hands-on specifically communicate with the computer what I wanted, how the website I wanted it to operate. Agents are the same way. And so if you ever hit a roadblock or you start to think, hey, this needs to be scaled or deployed to a separate place, awesome. You can eject all that code. It's primarily going to be Golang or TypeScript. And then from there, you can operate against like you would, in normal Modus app. Last thing I'll say is, again, we provide you one of everything from custom tools to knowledge graphs to end-to-end inference tracing. We make sure you've got what you need, and we've got lots of great customers. They build lots of cool stuff. But I think for this audience, showing what we actually make is the right way. Will, Amy, any questions from chat so far?
Well, I actually have a question from earlier this morning, and there are a few people on the call that we were having this discussion, and I think it might be relevant about not having trouble keeping up with all of the change that's going on in our space. And the concept of node RAG came up yesterday. It's a paper that was published, I think, last month or the month before. And then somebody else said, well, what about path RAG? And, there's just all of these different capabilities out there that we couldn't keep up with, even within our specialty area. And we had this really interesting conversation on really not caring about an extra 2% efficiency or perfection, but really just needing something that was easy for us to work with. And I think your point about iteration really, to me, felt like the right answer is like, how fastly can I iterate? Because I'm going to be moving. I don't care about perfection, but I just need to be able to play with this stuff. So I thank you for using that. But what are your thoughts on that concept and maybe what you were talking about?
Thank you for the softball. No, I cannot emphatically agree enough. I think one of the things that, again, agentic systems are catnip for nerds, and myself is very guilty of it. It's so easy to get caught up in, how do I, gild the lily and make it more perfect and more this? And then you go and talk to these people who are, working at a insurance provider in Middle America, and you show up and you say, hey, we could make that manual process just, a little bit better, but don't worry, unfortunately you're going to have to, review the work, and you've made their lives dramatically better. You've solved a meaningful problem, and even though we weren't able to catch that extra 2% of errors because, we were using, Node instead of some, other state-of-the-art graph embedding system. I think it's okay. I think over long periods of time, it becomes a responsibility of platform providers like Hypermode, where we start to light up these, people like Will, who are brilliant at this, start to light up opportunities for you to say, hey, I noticed that you're doing this method. Here is a baked-in mechanism for you to try the next thing. Here's a new recipe. Here's a new alt tab for that. And I think for those who are interested, it's a good way to spend our time and continue to expand the surface area of how we understand these systems work. But for the vast majority of our professional lives, we've discovered fire. We don't need to make the most perfect engine quite yet. Let's just make sure we're warming the houses and cooking food, and we worry about building space planes later. Yeah.
Well, and just to add to that a little bit, I mean, I think that working with open source tooling really is a benefit here, because it enables you to start with the basics, understand okay, what are the basic concepts here? What are the open source tools that I can fit together? And in your path RAG, node RAG example, let's just start off with a basic vector plus graph search and feed that data into my LLM. That's the basic concept of graph RAG, and sort of being able to incrementally adopt those pieces, I think is super important. And that's why I'm super happy at Hypermode, we have this platform and cloud hosting that is very opinionated about how all the pieces fit together, but it's all built on top of open source tooling that we can incrementally adopt and sort of explore on our own, which I think is super important for these kind of adopting these sorts of tools.
Well, just in the effort of time, I had more slides talking about how to build the thing, but I think what I'll do is I'll just show you the thing and use words. So imagine that you work at Van Gundy Farms. We currently have one whole employee. It's my dog, and she's not very good at working, but we love her anyway. And we're trying to manage Van Gundy Farms, and we've decided that a digital workforce is a way for us to actually be able to get a bit more work done around the house. And so there are a handful of different things that I can do to make the farm run a little bit better. Obviously, I have my vineyard operations plan, We use Linear because we're very cool, and we keep track of, what are we supposed to be doing today? We've always got this beautiful website, but there are a handful of tasks that I'd love help with. And so this is Hypermode. This is our agent builder tool. We call it Threads. And kind of similar to what I described earlier, in a low code way, I could start to build agents that solve problems for me. And so, for example, I'll build Mrs. Robot, an elite hacker, and I don't quite love the way Van Gundy Farms looks. I want to maybe update my header. And so, good coder, you're going to watch me alt tab over and copy and paste system prompts, just because I don't think anyone wants to watch me make a bunch of typos. And I'll briefly walk you all through what I'm doing. So the system prompt here that I'm describing is one, I prefer my agents to be concise. Don't talk a lot, but do tell me the tools that you're using. You're good at AI programming. For some reason, this helps. And then I give some specific instructions that, again, if you were building this the first time, maybe you wouldn't have this rich set of instructions. You might be starting out and say, oh gosh, hey, I want you to really think through what you're doing before you do it. Come on, you gosh darn intern, please do it. I'm cheating a little bit. And, I obviously, I'm trying to make sure this works as well as possible. And for example, one of the key hallmarks of agentic systems is they keep trying rather than just one in a row, like, okay, I tried to make it work and it didn't. You could ask them to say, keep trying, try 10 times, try 20 times, try 100 times. And then what you'll see down here, I call these memories, but in reality, these are things that would be discovered over the course of working together. Where, for example, I'm using our Hypermode Slack. So I intentionally give it like a channel ID so that I'm not making lots of noise in other people's actual work. Same thing on the Notion side, where I've created a sub page within Notion that's just for Van Gundy Farms. In reality, you wouldn't have to do this, but I'm just, again, trying to be precise. And then I can go down here and select the model that I want to work against. This is all changeable and tunable, where maybe you start out with Claude 3.7, you've heard good things about 4.1's coding ability, and you can swap those out at any point and say, oh, hey, I want to change this to X or Y. I found 4.1 tends to work a little bit better for me. Just its intuitions around tools is a little bit better. But again, your mileage may vary. And then obviously I need to start connecting different MCP servers, whether some of these are custom, some of these are off the shelf. My elite code probably needs access to GitHub, Vercel, Slack, and we'll all that good. And then for example, what I'm going to do is ask elite coder to do and update my header. The goal is to go to this thing, use Git search for my repos. Again, normally we'd be working against this. You'd probably just say, hey, let's go update the Van Gundy Farms header. And then you would have a conversation about building out this workflow. But I want to fire off some work while we build a couple other agents. So basically, go update the text, submit a pull request, and then give me the link to Vercel preview. And actually, I'm going to ask, send me a link to the work done in Slack. And so again, because we've wired up a couple of different tools, hopefully Mrs. Robot will be able to get this done for me. So while that one fires off, we might want to create another agent. Let's make Hagrid. He's my groundskeeper, helpful farm manager, also going to copy and paste over a system prompt. Very similar work of just like, hey, by the way, keep trying, do this other stuff. We'll try 4.1 mini on this one. I'll go ahead and create Hagrid. Where'd he go? Did I not click? Sorry, the danger of live demos. I guess we'll try again. We'll try and make Hagrid.
I love the different Lego personalities that you get. It's always fun to see like which one you're gonna get when you create a new agent. I like that.
Obviously, you can cycle through them as your preferences emerge. I'm gonna wire up Notion, Linear, and Slack. Over time, you guys may find that certain MCP servers are more or less brittle. One of the ones I'm struggling with a little bit right now is Linear. So we'll see if that one works. And so if you guys remember, we've got our Vineyard operations plan right here. I've uploaded a weather report to Notion just because I wanted to make sure that there's some bad stuff going on. And so on Sunday nights, I'm going to want Hagrid to go check the Van Gundy Farms Notion page, check the weather report, review our existing work plan. If there's anything bad going on, update our plan in Linear, then draft an email to the team, let them know the changes based on weather, and then paste that email draft in the Van Gundy Farms Slack channel and include a link to the Linear issue. Again, you can imagine some other like cron jobs that might be going on in your life where, maybe, hey, on Sunday night or every morning, go and look at my meetings for the day and go ahead and, research each person that I'm going to be working against, etc. And so what we ended up doing is like hopping back to this robot, like looking on her thread. Okay, so she's still working. Maybe these tools aren't going so well, or it looks like, oh, she's trying to get the deployment, but maybe can't quite find it. And so this happens not infrequently where, there might be just keeps trying. We can see if her PRD request did go through though. And so we can take a look at it. Oh, cool. That looks great. Let's go ahead and merge it. No, she's still thinking. We'll start a new thread with her and ask her to merge the pull request. Hey, go to GitHub. Let's see if she can do it. And again, you're going to find the right nomenclature and methods for communicating with your agent over time. And what ends up happening is once you've actually nailed that process and nailed the way in which you want to communicate with that agent, you can then snapshot that and save it and say, oh, great. And then we can just check them in Gundy Farm Slack. Mrs. Robot said, yep, I updated it. And we can go and check then Gundy Farms, give a quick refresh. Oh, we're probably waiting on the Vercel build. But once that rolls through, hopefully that'll be merged. Anything else we should flash here? But that's kind of the agent builder demo. You can do obviously much more sophisticated work. For example, I'm working on a brand builder who can do a bunch of research for us on more complex topics, where I asked him to do a product launch for us. But yeah, any other pieces worth highlighting here?
Well, I see a couple questions in the chat asking.
Oh, sure.
So there's one question kind of asking, like, are those list of connections all MCP servers? And maybe we can talk about like how that piece works. I'm going to go into a bit more detail on what MCP is in a bit here, but I think that's a good highlight. And then another question kind of related to that is like, how would you wire up sort of audio functionality to this?
Audio is an interesting one. One of the things we're actually going to be launching very shortly is streaming for Modus, which will allow us to do kind of like things like, what's it called, 11 labs and so forth. Theoretically, like the only delta would be the MCP servers you are working against. And so necessarily, I don't think much would change. But maybe to your earlier question about is everything here an MCP server, short like for the tool discoverability piece, you're giving that snippet, and we'll dive a lot more into this of describing what that tool is. But for example, I was working on this morning, and my Rickle Rubin, I've not figured out the quite right way to instruct him, getting me ready for a product launch. Maybe in the background while Will is presenting, I'll play with this and see if we can get Rick here to build us an entire product launch and get us rolling. Cool.
So a follow-up question to the MCP question would be, if you're currently working with or planning to work with Google's A2A functionality as well, so that you could have agents and different MCP servers involved.
So short answer is 100%. One of the things that I've actually found as I use this, we use this internally at Hypermode a lot, is very often, for example, GPT-4.1 is really good for code, does a great job, has pretty good tool intuition, but often actually kind of like the copy that it writes is not great, as well, to put it politely. And also the personas of the agents that I'd be working with, where, the way I want, Rick Rubin here to talk is going to be very different than the way in which I want my coding agent. And that handoff is so critical to be able to say, okay, once Rick has created our, our brand product launch guideline, I then want, Mrs. Robot to then go and take that and then update our header image to have, some sort of that push, some sort of header here that says, some banner that says, great new product is coming out, it's positioned well. And so we just really need agent to agent to work. We're doing it in the background with some sketchy plumbing, but doing that at scale, I think A2A is going to be super helpful.
And I'll add to that. Like, I'm super excited about some of the things coming out of Google in the generative AI and agent space. Like, I think they're doing a really good job of iterating in that space and taking advantage of like all of the like database tools and platforms that they have on Google Cloud, and sort of bringing like frameworks for building agents on top of that, and being very mindful to do this in an open source way. Like we were, as one example, we were early partners with Google on the MCP toolbox, which was previously called the Gen AI toolbox, which was all about exposing tools for databases, initially for Google Cloud databases. I think we were the like second external database to add support for Dgraph. So yeah, so we're working with Google on some of those projects, and yeah, I'm pretty bullish on what they're coming out within the AI space. Let me share my screen and we can dive into a bit more.
As you're doing that, there's a couple more questions, but I think I suspect you might be answering some of that, Will. So we can hold for a little bit.
Cool. Sounds good. So can folks see my screen? You should see a slide about knowledge graphs.
Yes, sir.
Cool. So let's talk a bit about knowledge graphs and Dgraph. And I want to revisit this slide that Kevin showed earlier. And this is all about like, what are all the pieces that you need to put AI agents in production? And there's this kind of like do-it-yourself approach, that you need to think about how you can evaluate models, think about memory, think about how do you expose tools, like all these sorts of things. And like a Hypermode, we're opinionated. We have this platform about how all these pieces fit together. And what Kevin showed with this like threads experience is kind of the like in the cloud, we're managing, orchestrating those agents for you. But under the hood, like that's all built and running on top of open source tools that you can incrementally adopt. You can build and deploy wherever you want. But like the goal is for Hypermode to be the best cloud hosting experience for that. And there are a couple open source pieces here that I think are like really important. One is Modus, which we'll talk about only a little bit today, but that's sort of our AI agent orchestration framework where we have abstractions for working with models and data. What I want to focus on for the next little bit is the graph piece of this. So knowledge graphs are, we think, really important for AI agents in two senses. One is to provide this like more enterprise-wide source of truth to provide the best context for your agents. But then at a more agent-specific level, this idea of agent memory. And so that's two ways that we leverage knowledge graphs. Both of these are working with Dgraph, which is a open source database that Hypermode builds and maintains. But before we dive into Dgraph, let's talk a little bit about knowledge graphs. I think this is the GraphGeeks group, so I think folks are familiar with this concept. I'm going to talk about knowledge graphs as an instance of a property graph. This is how I think about a knowledge graph. There are lots of different ways to think about this and have opinions here, but I think like one of the most important pieces of what makes a graph a knowledge graph is that you have a canonical representation of everything, right? Things, not strings, right? This was what Google said, and it's like 2012 paper that introduced the Google Knowledge Graph. So in this example, this is from a conference I was at. So you can see a node that represents me, a node that represents a friend of mine who is also presenting. And like we both previously worked for the same company. And so we don't have like duplicate nodes to represent this company that we both worked at or this conference that we're both at. When we have another piece of data that references that, we create a relationship to that. So some canonical representation of everything. And then of course, like the semantics, like how things are connected is a super important piece of this. In the property graph model, those semantics are encoded in the data model. So we have the relationship type that describes the semantics, how these are connected. We have the node label that describes the type of the thing. So that's kind of how we think of roughly what a knowledge graph is. Now I mentioned Dgraph. Dgraph is this open source project that Hypermode we build and maintain. Dgraph was first released in 2017, and it had an interesting approach to the graph database world. It's created by some ex-Google folks that were inspired by Spanner, if you're familiar with Google's Spanner distributed graph database. So really brings that strong opinionated way of optimizing for scale in the terms of data volume. So the D in Dgraph stands for distributed, so meant to handle large volume of data that needs to be distributed throughout a cluster. And Dgraph uses the property graph model for data modeling and querying, but interestingly uses RDF for data interchange, which may seem a little at odds. I know folks in this community are familiar with this distinction between property graphs and sort of RDF triples. And we typically think of these as like two very separate systems. But I think like there are similar ideas in both, and Dgraph leverages these for what makes the most sense. So the property graph model, we have nodes. Nodes have a label. We have relationships. They have a type and direction, and we can store arbitrary key value pair properties on both nodes and relationships. But then with this RDF triple concept where we have subject, predicate, object, right? Well, a subject, that's always going to be a node, a predicate. This can be a relationship or a property, and then an object can be a node or a property value. And so one sort of triple, think of that as like a concept or a sentence. That's kind of the smallest unit of data in Dgraph. So how do we go from property graph to thinking of in RDF triples? Well, the first step is that every node needs a unique node ID. This is important in a lot of graph database systems because typically this maps to some offset on disk. So in the file store, as we're traversing a graph, we're essentially like chasing pointers, going to that offset in disk. The next piece in how we can represent property graphs as triples is thinking of this RDF, this triple representation. So subject, predicate, object. We saw in the previous example, like a subject, this is always a node, and we use that internal node ID, that UID, the unique ID that points to some offset in disk as the way that we represent the subject node. Then the predicate, this can be a relationship or a property. And then the object is either going to be another UID to represent that relationship to another node or the value of a property. Dgraph uses this concept of a posting list internally to keep track of all of the nodes that another node is connected to, and then shards by the predicate. So when we're talking about distributing data, we make sure that those relationship shards are always contained together, so every node can very efficiently traverse any node it's connected to. If you're familiar with Dgraph, you'll probably have seen DQL, which is the Dgraph query language. This is query language we use primarily for interacting with Dgraph. When Dgraph was released in 2017, GraphQL was very popular at the time. This was an interesting API query language that was released by Facebook. But importantly, GraphQL is not a database query language. And so Dgraph borrowed some ideas from GraphQL and then extended some of those concepts to add actual database querying functionality. So if you're familiar with GraphQL and looking at DQL and see some similarities there, there's definitely some inspiration. So very much like GraphQL, DQL starts from some root criteria. And I think this maps quite nicely to this idea of graph database traversals. You typically use an index to find the starting point of your traversal and traverse out from there. And then in this piece, this is the selection set, which is this like nested structure. And essentially each nesting represents a traversal. In DQL, we also...
go ahead. I'm sorry to interrupt, but there's a really pertinent question about how DQL relates to the GQL standard and whether there's a relationship there at all.
Yeah, that's a good question. So GQL is a new ISO standard as of, I don't know, maybe earlier this year. I don't remember when it was actually finalized, but it had been in work for a few years to borrow some concepts from Cypher, from SQL, from some of the other graph query languages, to have kind of a high level standard for a graph database query language. DQL doesn't really have any relation with GQL. GQL, like I say, borrows some ideas from Cypher and some ideas from SQL. So I think the naming is, there's a lot of naming collisions in the query language space. But I think very much DQL is inspired by GraphQL. So that's kind of how I think of it. Yeah, great question. Cool. So let's take a look at maybe an example in action here. So let's take a look at a data set I've been working on. This is data from the New York Times about articles and the people mentioned in, the organizations mentioned in. But then we also introduced this concept of how do we work with unstructured data in the graph. So we take the article and chunk it and calculate embeddings. And this gives us, I think, like multiple entry points to the graph here. So we have sort of like the lexical graph, which these are the like embedded chunks that allow us to do vector similarity search that provide an entry point for the graph. But then we also have like geospatial indexes that can provide an entry point for the graph. I'm interested in news near some certain location and want to traverse from there. So let's see an example of this. So this is Vercel, which is a query workbench for working with Dgraph. I can run the basic schema query, which just shows me like here are the predicates I've defined. I have some embeddings on articles. I have images and these sorts of things. Let's take a look at some super simple queries just so we can sort of see what this looks like. So here's our root criteria is, let's start with the first 10 topic nodes, and then we're going to traverse out from there. So we're going to find articles connected to these topics. So here are some articles and topics. So the topic comedy and humor, articles connected to those. We can do something with a bit more complex initial sort of root criteria. Maybe we want to find all geographic areas mentioned within, this is 50 kilometers from, I think this is somewhere in New York City. And so the geo regions we're finding are like Brooklyn, Brighton Beach, East Village, Manhattan, and then traversing the graph from there to find articles connected there. And we said another entry point was this concept of vector search or similarity search. So we've generated embeddings for each article. And here I've calculated the embedding for, I think this is for the string money laundering. I used one of our embedding models that we host on Hypermode to do this and just passing this as a parameter. And so I can see here the articles that I've found that are close in vector space to this string money laundering. And here's something about like the Signal chat scandal. Here's ones about the scammer's manual, about leaked documents and these sorts of things. So conceptually, those sort of make sense. Cool. So that's a quick look at Dgraph and DQL. One thing that I think was really interesting at Hypermode is a few months ago, we decided to move all of the previous enterprise features of Dgraph into a single open source Apache 2 licensed build and offering for Dgraph. And so we're going to talk a little bit about this V25 release that's available in preview now. But just a little history here is that previously there were two releases of Dgraph, sort of a community edition that was fully open source Apache 2 that didn't include things like online backups, ACL, like these sorts of things. And I think at Hypermode, we realized like the interesting parts here in the Hypermode sort of product world are, how can we enable these sorts of agentic flows? Knowledge graphs are such an important piece of this that we want that piece to be fully open source so that folks don't have any qualms about adopting like this core knowledge graph piece. And so if we look at this V25 release of Dgraph, which is currently in a preview release, at the bottom here, these are sort of the existing enterprise features that we're improving and adding into this single Apache 2 licensed build, and then a few new features that are in there as well, like namespaces, so being able to have multi-tenant graphs, a simplified way of working with clients, and then this model context protocol server, so an MCP server, which we've talked a little bit about already. Let's drill into MCP a bit, and then we'll take a look at an example of working with MCP and Dgraph. Like fundamentally, MCP is a protocol that standardizes how our AI applications connect to and work with tools and data sources. You can think of it as kind of an evolution of like REST APIs that are standardizing how web applications interact with the backend, the language server protocol, how IDEs work with language-specific toolings. MCP, we're all talking or focused really on how AI apps interact with external systems. I'm glad someone appreciated my ICP reference there. I worked hard to get that one just right, so thanks for that. Cool. So some folks have described MCP as kind of like a USB-C protocol, right? Before MCP, if you're wanting to like connect to Slack, Google Drive, GitHub, if you're building like an AI application for this, you're kind of doing this sort of bespoke, unique way to figure out how to get this to work with your application. But now with MCP, is these services can build MCP servers that expose tools for how to interact with Slack, GitHub, etc. And you can leverage those MCP servers in your AI application. And this is exactly what Kevin was showing earlier in Threads. We had all of these connections, and those are leveraging the MCP servers for GitHub, for Vercel, for Slack, to enable the AI application like Threads, to enable the model to decide how to interact with those services as a way to act on that environment. We take like a step back, and you may wonder like, okay, well, why are we exposing tools to models and data? Like what's going on here? Well, like fundamentally, an LLM generates text, right? So we give it a prompt, it does some magic and then gives us some output. But to build an agentic system where the model is making decisions about control flow, we need to provide a way for that model to understand and interact on its environment. And that's what tools are all about. So tools are really, you can think of as like a function that have some like natural language description of what the function does and the parameters that the function takes. And then there's this sort of iterative loop where the model is given a prompt and a description of the tools that are available. And the model decides, well, to resolve this prompt, I'm going to call this tool with these parameters. Then the AI application invokes that tool and passes the new data. The model decides, do I have the data to resolve this? Yes or no, and iterates until sort of the query is resolved. And I will say, like, there are interesting cases for knowledge graphs in all three of these pieces, the retrieval piece, which we talked about a little bit earlier, like this graph rag concept, tools for curating knowledge graph, and agent memory as well. And so like really the benefit here, and if we take a look now at the Dgraph MCP server, right, the benefit for AI app developers is you can now connect your app to MCP servers with like no additional work. If you're building developer tools or APIs, you can create one MCP server once and it can be adopted anywhere. This is sort of the category for us building the Dgraph MCP server. And of course, for the users of these AI apps, well, now you have like extensive capabilities for your application. And also one that I think hadn't really occurred to me initially is like the benefit here for the enterprise is that you have very clear separation of concerns between your AI product teams. So I borrowed this slide from a deep learning .ai course that Anthropic put out recently on working with MCP. This is a really, really cool, quick course to go through if you want to dig more into this, especially how to build your own MCP server. But it's pointing out here is that, okay, an MCP server is exposing tools, which are these functions and a way for the model to interact with its environment, resources, which are like read-only, more static data, and then also prompt templates. So if we take a look at the Dgraph MCP server, the way we expose this is the Dgraph cluster itself exposes a MCP server on its HTTP endpoint. There's a read-only option. So if you just want to expose tools for querying the database, that's an option. But essentially, the tools are fairly simple. You have the ability to get the schema. So let's see the schema of the cluster, to run a query, run a mutation, alter the schema, and then to see some common queries. So what are some use cases? Like why would we use a graph database and Dgraph specifically MCP server? And I think Right now, what makes the most sense are for using in AI coding assistants like Windsurf or Cursor, and being able for the coding assistant to have access to, say, like the schema and be able to execute your queries. It's really useful for debugging queries. So there's a screenshot there where I was writing a script to execute DQL queries, and I wanted to use the schema to generate kind of a default, but very helpful. I've used this to find out where I don't have the right indexes exposed. Why am I getting the wrong results for a query? Well, you need to add a geo index. This sort of thing can be really helpful. And then the other case I think is for exploratory data analysis. And the Claude desktop app is really good for this, where you say, here's my Dgraph server, analyze this data, create some charts to help me make sense of it. And that's something that Claude, I think, is really good at, and is what we're going to take a look at in a minute here. So I'm going to switch over to Hypermode. So here's a graph that I created earlier, and here's the MCP configuration for this. I should say Hypermode, that anyone can sign up and create a graph instance. I currently have a free tier for this. And I'm going to go into Claude. So if you're familiar with Claude, it's Anthropic's sort of desktop tool for working with their models. And what I want to do is register my Dgraph MCP server in Claude. So we need to edit our configuration, which currently is just a JSON file. And I'm going to paste in, this is the configuration that I copied from Hypermode. And then we need to restart Claude to register that. And now, if I take a look here, these are the tools. Maybe I didn't save that. Let's give that another try here. Text edit, save, open Claude. What we should see here is the Dgraph MCP tools registered. Not sure why that isn't showing up, but let's take a look at an example that I ran earlier today to give you kind of an idea of what this looks like. So I said, create some sample data in my Dgraph instance that includes fictitious products, customers, and orders. And so this is with a blank Dgraph instance. And it starts off by looking at, like, okay, let's run the get schema tool and sees like, okay, there's nothing in there. Let's alter the schema to include data about, products, customers, orders, and then generates some sample data. And what's interesting about this is very iterative. So the model itself is coming up with the queries to run. Our Dgraph MCP server is really just exposing the ability for the model to connect to Dgraph. So we load some sample data, and the next piece is, okay, let's look at some example queries and create some visualizations. And so now it's sort of generating queries to analyze data and creating charts that help us make sense of the data, including on a timeline. And we end up with this sort of dashboard that it gives us at the end here. So a graph view, interactive graph view, and then here's our dashboard to help us make sense. And this is all sort of coming from data that the model generated to make sense of our data in Dgraph. So that's, I think, kind of the exploratory data analysis case. The other one that we mentioned is sort of when you're in one of these coding assistants, being able to sort of edit your code directly. I'm going to skip over the last piece here because we're about out of time, but we talked about this earlier. Modus, this is our sort of agentic framework, and this is what we use to actually orchestrate this tool calling and connecting to Dgraph. And I'll end here just talking about the threads functionality that Kevin was highlighting is currently available in early access. So if that sounds interesting, definitely sign up for that.
Awesome. Thank you very much. I am going to allow us to be open for a couple minutes just to answer a few of the questions. If you have a burning question, get it into the Q&A as opposed to open this up for general discussion right now, I think for timing purposes. But there are a couple really interesting questions that I think would be good to hear from you on. In particular, one is about the memory and how that works. So behind the scenes, how does the memory work? Is there graph memory there, like graffiti?
Yeah, so So essentially, the way that agent memory works with Modus and what we're showing here with Dgraph is essentially there is an embedded version of Dgraph called Modus Graph that's included in every Modus project. And there's an MCP server that implements, I think there's a paper by Anthropic that talks about how to model agent memory as a graph. And that MCP server is able to construct a graph from agent interactions. This is something that we're open sourcing, I think, later this week, maybe. So definitely stay tuned. If you're in the Hypermode Discord, or if you follow us on the blog, there should be an announcement pretty soon about that, making that available for general use. But yeah, there is graph memory using an embedded graph database, or also against Dgraph as well, if you want to share that memory sort of across your agents.
I like that idea of sharing memory. One more question that I think is very interesting is the request to explain the concept of RDF or JSON interchange. So I think that, the interchange between the different data types caught some attention as well.
Yeah, and I think this is really an area where RDF shines is for data interchange. With Dgraph, we use this concept of RDF in quads, and so you're basically constructing triples that map to the property graph model that we talked about. So for example, Dgraph uses a convention. There's a predicate dgraph.type that contains the node label and these sorts of things. What's nice about this is this enables really fast data import tooling. So a lot of the data import tooling for Dgraph is RDF based, and we have some tools for converting CSV and JSON to RDF. But yeah, I think that's taking advantage of one area that I think RDF really excels at, which is the data interchange piece for sure.
Okay, awesome. And I think one question you might have answered already. If I missed that, apologies. But do your agents actually interact with each other, or are they solely independent?
They're currently. They're currently independent. But probably if you guys sign up for the agents waitlist, maybe the next week or two, those with early access might have agent-to-agent access soon.
Awesome. Wonderful. I love that. I love that teaser as well. Great. I will say I am always impressed by how quickly your team iterates on things. So velocity is king, I feel like, at Hypermode, hence the hyper part of it. But I think we should probably leave it there for now for questions and allow people to move on with the next appointment in their schedule. I will say, please feel free to reach out to Will or Kevin on either GraphGeeks. If you're there, they are very active there, but there also is a Hypermode Discord server as well. So there are definitely a lot of people there that can help you out. Any other final thoughts, Will or Kevin, that you want to leave everybody with?
I guess all I'll say is, one, thank you, Amy, for having us. And then two, I emphatically ask you guys, if you want to build something that makes your life a little bit better today, sign up for Hypermode and the Agent Builder, and build something and automate some of your day.
For sure. And I shared a link to the slides here. If folks want to grab those, there's some good resources in the slides. Definitely feel free to check those out. And join us in the Hypermode Discord. And like Kevin said, give it a try. Everything we showed here is open source and available to be used.
Awesome. Great. Everybody, thank you. Have a great day. We'll see you all online.